The E7 gains larger displacement, greater power, and lower weight through increased stroke and the use of a new cylinder block with wet-dry cylinder sleeves. Now let's begin this overhaul by checking the block. After the block is cleaned and tested for cracks and leaks, check its deck surface for warpage and fretting wear. If warpage or fretting wear exceeds specs, have the block deck resurfaced. Inspect the cylinder block sleeve seats. If any of them are damaged or pitted, they must be recut. In addition, if the block is resurfaced, the sleeve seats must also be recut to the proper depth. Next, check the cylinder bores for out of round and taper. On the E7, you have to check the lower dry portion and the upper wet portion of the bore. Inspect the lower part of the bore as you would any other dry liner bore. Take 2 readings at 90-degree angles in these places, just below the sleeve seat, at the bottom of the bore, and midway between the two. You only need to check for the proper diameter and out of round in the upper portion of the bore where the sleeve contacts the block. If any bore is excessively tapered or out of round, it should be machined to accept an oversized sleeve. Measure the depth of each cylinder sleeve seat. If one exceeds specifications, recut the seat to increase or install shims to decrease the depth. Place the lower cylinder sleeve seal in its groove in the cylinder bore. Lightly lubricate the seal with MAC O-ring lubricant. Install the crevice seal on the cylinder sleeve. Lubricate this with ethylene glycol type engine coolant. Next, put a 160 thousandths inch thick bead of the proper Silastic on the cylinder block sleeve seat. Push the sleeve into the bore as far as it will go. To completely seat it, hammer it down as shown using a large, soft-faced mallet. Install all the other cylinder sleeves in the same way, and use hold-down bolts and washers to secure the sleeves in the block. Measure the sleeve channel heights to be sure they are within specifications. Measure at 4 places, 90 degrees apart, and compare the average of these readings with specifications. If one sleeve is out of limits, remove it and check for a rolled seal or dirt or other debris on the cylinder block sleeve seat. As on all MAC engines, the location of the oil spray is essential to cooling the piston. So turn the engine upright and check the spray location of each nozzle using the special tools. If the rod is less than 1/8 inch or 3 millimeters out of the target area, bend the nozzle slightly at its hooked end until the rod is in the target. On the other hand, if the rod is more than 1/8 inch or 3 millimeters out of the target area, replace the nozzle. After checking the rods, measure the piston ring end gaps. If any are out of specification, do not file the rings to obtain the proper gap. Instead, install the ring on another piston in a bore where the gap is okay, or use a new ring. Some E7 engines use 2-piece pistons. Installing these is similar to the process for single-piece pistons with a few exceptions. Since these pistons have only 3 rings, stagger them like this. To assemble the piston on the rod, first install one of the pin snap rings. Then put the piston skirt and rod into position and slide the piston pin into place. Install the other snap ring to complete the assembly. To install a piston and rod assembly, whether it has a one- or two-piece piston, first thoroughly clean and degrease the rod and cap bearing surfaces and the backs of the rod bearings. Then press the proper upper bearing half into the rod. This bearing is marked upper on the back and has an oil hole. Then install the lower bearing half in the cap. This bearing is stamped lower and does not have an oil hole. Lubricate the piston rings and install the piston and rod assembly in a piston ring compressor. Lubricate the upper rod bearing half and the cylinder sleeve with engine oil. Turn the crankshaft until the crank pin for the piston you want to install is at bottom dead center. Locate the piston assembly in the bore with the front mark on the rod toward the front of the engine. Then push the piston and rod assembly into the cylinder bore. Be sure the big end of the rod does not bend the piston cooling nozzle. Lubricate the lower connecting rod cap bearing and install the cap. Hand tighten the cap screws. Install all the other piston and connecting rod assemblies in the same way. Now check the connecting rod bearing oil clearances with Plastigauge. To obtain a good reading, the engine should be upright and the upper connecting rod bearing should be fully seated on the crank pins. Correct any oil clearance problems. Then remove the Plastigauge material. Lubricate the lower cap bearings and loosely install the caps using new bolts. Before torquing the cap bolts, align each cap to its rod by inserting two equal width thickness gauges at the parting lines. Then tap the cap toward the gauges until the cap and rod are flush at both parting lines. Check that the crank rotates after tightening each cap to specs. If it doesn't, a side or oil clearance problem exists on the last cap you torqued. Now check the piston to block deck height. If the block was resurfaced or some connecting rods were reconditioned or replaced. If this height exceeds specifications on any piston, make sure that you've installed the correct pistons and that the minimum block deck height is within specification. With all the caps installed, tap each rod to one side and check the amount of side clearance between the rod and crank. If clearance does not meet specifications, recheck the cap to rod alignment.